So the second part of this process of hemostasis is clot formation. Come on. There it is, clot formation. So in the body, we secrete two types of chemicals. Okay, the vessels secrete two types of chemicals. One type of chemicals are called procoagulants. So what does that mean? I think pro, something, excitive or whatever. So these types of chemicals increase clotting in a vessel. They also have things called anticoagulants. And these things decrease clotting. So in normal conditions, so conditions where things are just going, there's no injury, nothing like that. Basically, anticoagulants are going to be high. They're going to be secreted because if you're not bleeding, you don't need your blood to be clotting. Okay, that would be bad. So we have anticoagulants that keep blood and platelets from clumping up and causing clots when you don't need one. So procoagulants start to secrete in times of blood loss. So increase in times of blood loss. So these procoagulants function in two different ways, in two different pathways. So these are basically cascades of reactions. These two types of pathways are cascades of reactions that basically result in the same thing. So there's two types of pathways. There's the intrinsic pathway and the extrinsic pathway. And I'm not going to go into how those two things work or when they're dominant or whatever, because it just doesn't really matter in our conversation. What matters is that these two pathways end up in the same spot. So they end up, both of them, end up activating something called Prothrombin Activator. Okay? And this chemical, enzyme, if you will, basically what it does is it takes prothrombin, that in a different color, which is a plasma protein, so prothrombin, and it converts it into thrombin. So prothrombin is a plasma protein you have all the time, but it requires the pathways of these procoagulants to turn it into thrombin. Okay? Now, prothrombin is a plasma protein, and it is produced in the liver. Okay, and it's produced in the liver, and it comes from vitamin K. Okay, so that's prothrombin. Once we have thrombin, that thrombin takes another plasma protein called fibrinogen. And we talked about fibrinogen before because it is a plasma protein, and that was one of the constituents of blood we talked about. So, fibrinogen. So again, I'm going to call this a plasma protein because that's what it is. And it converts fibrinogen into fibrin. And fibrin is a substance that weaves together and sticks to everything it comes into contact with, making a big net, which is a clot. So it weaves together and sticks to everything, basically everything in vicinity. So sticks to all this stuff and weaves it together, and it makes a big net. And that net is the clot. Okay, so it gets like blood cells and whatever else's stuff is there. It just weaves it all together into this big nasty clot thing that takes over for the platelet plug, because the platelet plug, again, is not going to be strong enough to withhold the blood coming by and all of that. It needs something stronger to hold for a longer period of time to allow for healing. So that's the clot. The clot will go through some changes, and one of the things is retraction. And retraction occurs when the platelets from the plug release calcium ions, and that causes contractile proteins in the clot to contract. So they contract and then they tighten. And fluid, it kind of squeezes fluid out, kind of oozes, that little white nasty stuff that comes out of a scab that you have, creates a scab, and that kind of barriers off the area so it can heal. So the area around it, so I showed you, we have this blood vessel, and we've got this injury here, and the area around it is secreting chemicals, and one of those chemicals, of course, or a portion of those chemicals, are procoagulants. But what happens over here in the healthy tissue? The healthy tissue is still secreting anticoagulants. Because we only want a clot here. We don't want it all over the vessel, because that would be bad. We only want it here. And once the clot forms here, so we've got this clot that's over it, stops the bleeding and allows for healing. It then starts to secrete chemicals that start to break it down. Once healing occurs, then we have other chemicals that are released there that break that clot down because we no longer need it. So you may be familiar with, just going to put this over here in this little side box here. So if you've ever heard of Coumadin, Coumadin is an anticoagulant that people take or given, just if you've got, cardiovascular disease or whatever. And what it does is it inhibits the production of vitamin K. So what does that do? Well, we see right here, we need vitamin K in order to make the plasma protein prothrombin. So if there's no prothrombin, we can't get prothrombin to become thrombin. So then we can't get fibrinogen to become fibrin. So we don't make clots. Aspirin is something a lot of people with cardiovascular disease take. Oh, take an aspirin a day. Well, what does aspirin do? Aspirin is a COX inhibitor. And COX is an enzyme that helps produce thromboxane A2. So if we don't have thromboxane A2, we're going to have trouble activating platelets. Okay, so that is hemostasis. That is the stoppage of bleeding. Again, make sure you know all these steps, but I will not ask about the intrinsic pathway or the extrinsic pathway specifics about it. Just know that they exist, and those are the procoagulant reactions that ultimately result in prothrombin activator, which is what is important here.